all sorry that I forgot to hit record. So I thought I would run through these slides really quickly just in case there was anything you missed or anything you wanted to know. So here's a quick look at the graph that I made for the question that you guys did in the breakout rooms. So again, the main point here is that you want to make sure that you've hit all 5 of the criteria, that all of those things are there. And as we talked about in class, kind of what I do first is draw on those points, draw on the behavior around the asymptote. I got a little fancy with our limit as x goes to 5 being equal to 2. I decided to put an open circle there. It could be a filled in circle. It doesn't have to be like a funny piecewise function like I made it. I was just trying to do something a little bit different and interesting. And remember, your graphs can look a little different from this, but that's okay. As long as it meets these 5, these 5 criteria that we have, that's the main thing. So then we moved on to looking at some limits with direct substitution. With all those limit laws that we have, we can directly plug -2 into this function because it's going to be a quadratic, or not a quadratic, it's a 4th degree polynomial, like I kind of have drawn up here. And no matter where we are on this function up here, when we're approaching an x value from both sides, we're going to get to the y value. So we can just straight plug -2 into each of the places for x. And we do want to remember to be just a little bit careful with our calculator and make sure that we get parentheses around any negative numbers that we're squaring or raising to a positive power. We had the same type of question here with the limit as x was going to -4 of this rational function. We should always try plugging the number in first and seeing what happens. And in this case, we get 0 divided by -8, which is totally fine, which is 0. Now, this is one where we have a little bit of an issue. When we plug in 4, we get 0 over 0. That's one of those indeterminate forms. But something we can check for when we have an indeterminate form is if either the top or the bottom of this fraction factors. The top of it factors, and we can cancel that x minus 4 on the top and the x minus 4 on the bottom, and it leaves us with a function that we can use the limit laws on, and that we can just plug 4 into, and we get our limit equaling 8. Now again, you could also plug in a couple of values that are close to 4, like 3.99 or 4.001, to see what y value we're getting close to, and that's going to work too. They both should be getting close to 8. And then we finished up by talking about, sorry about the loud ding there, that if you heard that, is that when we've got a polynomial or a rational function, we can do what's called direct substitution, as long as we're not taking that point where the denominator of our fraction is equal to 0. We can plug in that value for that limit, and the y value of that function is what our limit's equal to, which makes it pretty straightforward. And then we had our to-do list. We got a couple Newton Altas. Something I've learned is you've got to access this limits function, or this limits and graphs from our links in Canvas. And let's see, we've got the written homework 0 that's due, and that's the practice. And then an actual written homework 1, so you can take a look at, that's due too. And everything for day 3 is all posted. So again, sorry that I somehow just didn't hit record. If there's any questions you have about any of this stuff, just let me know. Happy to answer it.